Okay, A2 trigonometry. Now, this is assuming that you know the AS identities, which basically mean you should know that sine theta divided by cos theta is equal to tan theta. You just learn it. Honestly, just learn it. Sine over cos is tan. And I assume you'll know that sine squared theta, and my secondary light just went out, plus cos squared theta is equal to 1. Now, I can give you the very quick proof of that if you want it. It's not too difficult. It's basically triangle. Here's a triangle, here's theta, it's a right angle, and this is the hypotenuse. This is the opposite, and this is the adjacent, and sine theta is equal to over h cos theta is equal to a over h. And then if I said, okay, let's use Pythagoras. If we use Pythagoras as theorem, we know that a squared plus b squared in O equals c squared. So I could say that that plus that is that, or I could say that sine theta, so O over h squared, square both, plus cos theta is equal to h squared. So it's going to be h over h squared. So oops, a h that is equal to sine squared theta plus cos squared theta, which equals 1. When I say using Pythagoras, that is this. I'm saying that that side squared plus that side squared equals that side squared, as Pythagoras would state. But then what we're doing is we're simply just deciding to divide everything by h squared, which we know that, and that's how you get that formula, just in case you want to know why or where that comes from. Okay, so now for the ones that are new at A2, we have cosec theta, we have sec theta, and we have cot theta. And these are equal to the normal ones, so sine, cos, and tan, but it's 1 divided by sine, cos, and tan. So this is equal to 1 over sine theta, this is equal to 1 over cos theta, and this is equal to 1 over tan theta. It's kind of slightly easier to remember this if you think of the third letter. Honestly, how I do it. So cosec, S for sec, S for sine, sec, C for sec, C for cos, T for cot, and T for tan. That is actually how I remember it. And you know, if you want a little bit of extra thinking about this one, if cot is 1 over tan, that means that cot theta is also cos theta over sine theta. Because that is literally 1 over tan. That's another way of thinking of that one. Yep, another one. So, more identities that you need to learn. We have this formula here. What we're going to do is we're going to take this and we are going to, let me get another colour, divide it all by sine and then divide it all by cos. So, sine squared theta, and I do this on exam papers or questions all the time just to make sure I get the right answer. So let's divide it by sine squared theta, divide this by sine squared theta, and let's divide this by sine squared theta. What do we get? Sine squared theta over sine squared theta is equal to 1. Cos squared theta over sine, well, we said that's cot. Cot squared theta, 1 over sine is equal to cosec. I like to remember this one by the fact that it's going to be cosec with a C, cot with a C, and there's the 1. I think that's kind of a nice way to remember it. Cosec, cot, 1. So this is the one that has the C's in it, and you'll see why it's different to the other one. So if we rewrite this, we get sine squared theta plus cos squared theta equals 1. Divide it by cos squared theta this time, plus, not a plus there, it's already on the top line, cos squared theta and cos squared theta, then you're going to see that sine over cos is tan squared theta, cos over cos is 1 over cos is sec squared theta, and there are no c's at the start of this, which is how I remember that one. You can obviously rearrange these to change the form slightly, but however, these are the new identities that are pretty much essential to learn. I would highly recommend learning these very well and using them. However, for these two here, I, in exams, will always write this out because I do not want to forget it, and I do not want to get the 1, is it a plus 1, is it a minus 1, remembering that it's going to be cosec squared theta minus 1 is equal to cot theta. I don't want to get that wrong, so I will write that out just to make sure. This leads us nicely onto identities, and the first one is going to be sine, if I can actually write, sine theta tan theta plus cos theta is equal to, or identical to, sec theta. And you may be wondering, well, how on earth am I going to go about this? You have to start at one side and make it into the other side. That is how you answer these questions. Might help if you remembered that sec theta is going to be 1 over cos theta. So that's actually what you're aiming for. And once you get to 1 over cos theta, you know that you can just convert this side into sec theta from that. But we're going to start working with the harder side. I always start with the harder side. Sometimes you'll try one way and mess up and have to go the other way. That is perfectly okay. But I see a tan, and as soon as I see a tan, that rings alarm bells, because I'm going to rewrite sine theta tan theta as sine theta multiplied by sine theta over cos theta, because we know that is equal to tan theta plus cos theta. Well, we can rewrite that as sine squared theta over cos theta plus cos theta. Now if we wanted to add these, cos theta is equal to cos squared theta over cos theta. You can think of it that way, or you can think about if you were adding fractions, that's over 1, to make a common denominator, you would multiply that up there and then just add them as normal, because there's obviously a 1 already there. So you're going to get sine squared theta cos, there's cos theta, multiplying that up by cos theta. They are added. I forgot to put the addition sign. You can see that obviously we're adding the fractions. 1 plus cos squared theta over cos theta. Remember, we've made the common denominator cos theta. We know that this is equal to 1. You could, I'll do it in purple. You could do this. 1. Some teachers will do that just to let you know that that goes to 1, but you can then rewrite that as 1 over cos theta. We said we wanted 1 over cos theta, which is equal to sec theta as required. I like these. Just make sure you don't make a stupid mistake like I did whenever you're adding the fractions and forget to put the plus, because if you forget to put the plus, you're not going to remember to get 1 from that. Okay, so a second one we're going to do is going to be, let me see, sine theta minus cosec theta squared is identical to sine squared theta plus cot squared theta minus 1. Now I'm going to start by multiplying out this bracket. You may think that's a weird thing to do, but multiplying out brackets is not too difficult. Just pretend that it's an x and a y. That's really what I do. So you could rewrite it. I'll just do it by thinking about the second bracket. So sine squared theta times, or sine theta times sine theta, sine squared theta plus, or minus cosec theta minus cosec theta, and then plus cosec squared theta. So minus sine cosec, sine theta cosec theta, minus it again, put a 2, plus, minus minus plus, minus, or plus cosec squared theta. Now, what's the next thing you can think to do? Well, you could imagine, what is sine theta cosec theta? So cosec theta is the same as 1 over sine theta. That is sine theta, so sine theta multiplied by 1 over sine theta is sine theta over sine theta. that's going to go to 1. It's literally sine over sine. It's going to go to 1, but remember there's 2 there, so it's actually 2. And then we can use the one with cosec theta, so we have sine squared theta minus 2, don't forget about that 2. Cosec squared theta is equal to, remember c for cosec, c for cot, so 2 plus cot squared theta plus 1. Okay, now what we can do is look up here. We've got our sine squared theta, we've got our cot squared theta. Minus 2 plus 1 is minus 1. Sine squared theta plus cot squared theta minus 1 as required. So that was maybe slightly harder one. I think we might do one harder one. Yeah, we'll do a hard one with a lot of substitutions. Okay, so here's the next identity. Tan to the power 4 theta plus tan squared theta is identical to sec to the power 4 theta minus sec squared theta. Now, if you remember, there's a relationship between sec and tan. What I sometimes like to write out the side of my page will be sine squared theta, we're just going to write it as s squared, plus cos squared theta, write it as c squared, is equal to 1. And then if we want to get to secant, we know that's something to do with cos because of the c. We're going to divide by cos squared, cos squared, and then you know that you're going to get tan squared plus 1 is identical to sec squared theta. Now, why is this a good thing? We know that tan squared theta is equal to sec, why am I tapping? Sec minus 1. It's good to remember. I just like to have that written out so that I don't make a very stupid mistake by adding 1 by accident. So, tan to the power 4 theta is the same as tan squared theta multiplied by tan squared theta. Tan squared theta, as we just worked out, is equal to sec squared theta minus 1, sec squared theta minus 1, plus sec squared theta minus 1. I forgot the theta. Pretend it's there. Okay, now let's multiply this out. Sec squared theta times sec squared theta is sec power 4 theta minus sec squared theta minus sec squared theta minus 2 sec squared theta minus 1 plus 1 plus sec squared theta minus 1. Now 1 and the 1 cancel out. Minus 2 sec plus sec is minus 1 sec. So sec 4 theta minus sec squared theta, and my side lights went out. Good for them. Is exactly what we have here. And so we've proven it.